Hi, welcome to our introduction to quadratic functions. I really like that word quadratic functions. Actually, I like the word quadratic because it is very curvy. See all the curves I make when I write it? I wonder if that's going to be important. It's much more curvy than linear. Linear, that's all those letters are so straight, except for the last one. Well, we've learned about linear functions already, and we know that the parent function of all lines is y equals x. That is the parent function. And if we wanted to graph that, we could just pick some values of x. I'll pick, I don't know, -2, -1, 0, 1, and 2. And I'll plug those into my equation, and I'll get the values for y. So y would be 2. If x is -1, y would be -1. If x is 0 and y is x, then it would be 0. And you can see how we would fill out this table. And then we could graph it, and it would be graphed just like it's shown. So this is -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. And you would see that we would make a line. Hey, this line has a slope of 1 and a y-intercept of 0. So remember that y equals x is the same thing as y equals 1x plus 0. Just a bunch of little things I wanted you to remember about lines. This is a linear function. This function is linear. It is a line. Now, we're going to talk about something called quadratic functions. Remember that curvy word quadratic? The parent function of, I'll write that down for you. Quadratic functions. And the parent function of all quadratic functions, is y equals x squared. Y equals x squared. I'm sure you've graphed that before, but we're going to graph it. Let's pick some x values and see if we can't come up with some y values. So let's be interesting here. X is -3, -2, -1, 0, 1, 2, and 3. And if I'm trying to figure out what y has to be, I know my function is y equals x squared, so I'll have if x is -3, then y will be -3 squared. Remember those parentheses. And so -3 squared would be +9. Very good. The -2 squared would be 4. -1 squared would be 1. 0 squared would be 0. I'm going down. Let's say up 1 squared. Wait a second. I'm going to change in direction here. 2 squared is +4, and 3 squared is 9. So if I were to graph that, I would plot -3, 9, -2, 4, and I would end up with, let's see, this graph right here. -3, 9, -2, 4, -1, 1, 0, 0, and then you can see it's actually changing direction and going up. So interestingly enough, when I had a linear equation, my slope was the same between any 2 points. Because if my function is a line, then what's not changing is the slope. So as I increase my x here, my change in y remains constant. Oh, who didn't put a negative there? So I'm adding 1, and I'm adding 1, and I'm adding 1, and I'm adding 1. See if you can figure out what the differences are in the x values and the y values on your chart. Maybe you can look at it and maybe you can come up with some kind of pattern. See what you can think about. And we're going to move on. Same graph that you have. I have just made it bigger. So you're looking at this graph, and we're going to talk about what makes something a parabola and what makes it special. You can tell that it's curved. Now, all parabolas have something called an axis of symmetry. It's like an imaginary vertical line that you can place, as you can see right there. And it divides this parabola into 2 symmetrical halves. And you know that it's symmetrical. You can see that if I have a point that is 1 away from it over here, there'll be a point that's 1 away from it over here on the other side. If I have a point that is 1.27 units away from it, there'll be a point that's 1.27 units away from it on the other side. Okay, so you can see that this is symmetrical with respect to this axis of symmetry. And it always goes through a very special point on a parabola called the vertex. The vertex is right here. Let me go ahead and label the axis of symmetry. This is the axis of symmetry. Now let's figure out what those values are. Okay, so the axis of symmetry is a vertical line, and it looks like it intersects the x-axis, in this case, where x is equal to 0. So that's actually the equation of my line. My axis of symmetry is x equals 0. That's that line. X equals 0 is that green line that you see right here. And it's passing through my parabola at the vertex. What are the coordinates of my vertex? Well, in this case, since it's the parent function, and the coordinates of my vertex are 0, 0. My axis of symmetry will always go through the vertex. And the vertex is going to be your highest or your lowest point on a parabola. So if your parabola is opening up, like ours is open up, the vertex is going to be the lowest point. If our parabola looked like this and was opening down, the vertex would be its highest point. And you'll notice that your axis of symmetry is your x value. And your y value right here will be called either your minimum or your maximum, based upon whether it's the highest or lowest y value in this parabola. So in this case, my y value is my minimum. Okay, my minimum, that's 0. That's the lowest y value I'm going to have on this parabola. Okay. I want to talk to you a little bit about the domain and the range of this parabola. Typically, the domain of parabolas, if they go on forever, is all real numbers. Let me erase that. All real numbers. Now remember, the domain are all the possible x values. I can take my table and I can put any x value into my table, y equals x squared, and I will get an output value. Whether I choose this x, I'll have a y value. Whether I choose this x, doesn't really matter. I can always plug x in, and I'll get a y value. But can you see, based upon this graph, that there are some y values that I will never, ever get? I will never get a y value of -1. My parabola doesn't go down that far. No two real numbers, no real number squared will ever give me -1 or -2 or -9. Okay? So you can tell that my range, all the possible y values that I would ever get, all the outputs that I would ever get from this function, the lowest one would be 0. The lowest one I would ever get would be 0. And it could be 0. And it's all the values that go higher. So how do I represent this as a range? I know I'm talking about my y variable. So I know that my y value, the smallest value I can have is 0. And there's no boundary to the highest y value. So I can just say that y has to be greater than or equal to 0. Or you could say 0 is less than or equal to y. Either one. Which one makes you happy? One more thing I want to show you. Actually, two more things I want to show you. I care about whether this parabola opens upward. We talked about that. I care what its axis of symmetry is. I care what its vertex is. I also care what its y-intercept is. Can we see what the y-intercept is? Well, in this case, this is the parent function. It's 0. Crosses it right here. And it crosses the x-axis where? Oh, it also crosses at 0. My x-intercept is 0. Now, this is a new idea here. This x-intercept, we're going to call that the zeros of the function. The zeros, or the roots. Wherever it intercepts the x-axis is going to be called the zeros or the roots of the function. So in this case, how many times does this parabola intersect the x-axis? Once, right here. So the zeros of the function or the roots of the function are just 0. Now you can kind of see if I would take this parabola and move it up. Let me kind of draw it moved up. Or just have another one that's moved up. How many zeros would there be in this function? Does it ever cross the x-axis? Will it ever cross the x-axis? No, it never will. So this function has no zeros, has no roots. You can also see if I had a parabola that was lower, how many times does it cross the x-axis? This function has 2 roots. 2 roots. I could have a function that looks like this. How many roots does this function have, this quadratic function have? It has 2 roots. One there and one there. Okay, let's move on. Hey, who remembers this? When we were defining polynomials, we were talking about how we classified polynomials. We talked about whether they were constant, linear, quadratics, cubics, and we've studied linear functions, and an example of one would be like y equals, I don't know, 2x plus 7. And the highest exponent, the degree of this function is 1. Because the highest value that we have, the highest exponent that we have is 1. We're now studying quadratics, and its highest degree is going to be 2. So an example of a quadratic could be y equals, I don't know, 3x squared minus 4. That's an example of a quadratic. You see that x squared? That tips you off. And you'll end up getting a parabola, a curved, it'll be a nice curved function. Here's a parabola. We're going to talk about it. Let's see what makes it what it is. Let's see. So can I identify the axis of symmetry? Let's see if I can bring this axis of symmetry and see if I can find the one that divides it into 2 symmetrical. There you go. Symmetrical parts right there. Can I define this line? Yes, I can. It's going to be x's, let's see, 1, 2, x is 2. My axis of symmetry is the line that's defined by x is equal to 2. Now, can I figure out what my vertex is? The vertex is always a point on my axis of symmetry. I can actually see it on this graph right here. Now, I can't always see it, but here I can see it. And its coordinates are 2, 3. You'll notice that the x value of my vertex is my axis of symmetry. Let's look and see if I can figure out what my y-intercept is. Identify the y-intercept. It's only going to be 1 because it's a function. Here we go. Here's my y-intercept. So my y-intercept is going to be -1. Y-intercept is -1. Let's see if I can figure out the roots or the zeros. Same thing. The zeros of this function. Let's see. Does this cross the x-axis anywhere? Oh, yes, it does. Crosses it there, and it crosses it there. Ah, all right, cool. So I have two roots, or I have 2 zeros. You can say it either way. So this function has 2 roots, and can I figure out what they are? No. Can you see what those are? No, we really can't tell yet. We can't tell just from the graph. We'll need to use some other strategies that we'll learn later. Okay. But what I can tell is I know it's going to be somewhere between 0 and 1 is one of the roots, and another one of the roots is somewhere between, what is it, 1, 2, somewhere between 3 and 4. Yeah, that's another one of the roots. So it's going to be somewhere between 0 and 1 and somewhere between 3 and 4. It's really interesting because if you go down here and you look at this table, which is actually the table of this function. We don't know what the function is yet, but this is the table. You can see that somewhere between 0 and 1, when x moves from 0 to 1, somewhere it's crossing that x-axis because I'm going from negative to positive. Do you see that? It's crossing it right about there. And then somewhere, between 3 and 4, somewhere between 3 and 4 will be another root because it's changing from positive to negative. So maybe you can recognize that. All right, now let's talk about the domain and range of this function. The domain is going to be all real numbers because you can see that this parabola keeps on going forever. And I can choose any x and I'll get a value of y. But I'm never going to get a value of y that's going to be bigger than 3. Yeah, the 3 is the highest value of y I'm ever going to get. So I could get 3, so it's going to be a closed circle, but I could get anything beneath it. I'm not going to get anything above that. So my range 3 is going to be greater than or equal to all my values of y. Or you could say y is less than or equal to 3. Any way you want to think about it. Sound good? Let's move on. Okay. Here I've got myself another parabola, and let's see what I can figure out about it. Can I figure out its axis of symmetry? Yes, I can. What is my axis of symmetry? It's going to be x equals 2. My vertex, I can see it right here. So my vertex is going to be 2, 1. Hey, notice that axis of symmetry is the x value of my vertex. Let's see if it has any y-intercepts. It should. It's a function. So here we go. Bam. There's my y-intercept. So it's going to be 1, 2, 3, 4. My y-intercept is going to be 5. Let's find its zeros or its roots. Remember, that's where the function intercepts the x-axis. It's where y is 0. Let's see. Oh, it doesn't look like it's going to ever hit the x-axis. I'm never going to get down there, am I? So, yeah, there's no chance. So there are none. There are none. See if we can figure out the domain and the range. Okay, well, my domain is going to be all real numbers. I can pick any value of x and find a corresponding value for y because this goes on forever. It keeps on going out. But are there ever any values of y that I could never get? Yeah. The lowest value of y I'm ever going to find is right here, which is 1. And 1. I could get 1, but and I could get anything higher than 1. But I will never get anything that's lower than 1. So my range is y is greater than or equal to 1. Anything else we can talk about? I think it looks good. This one's for you. I want you to write down everything you can possibly write down about this parabola. I want you to tell me whether what the axis of symmetry is, the vertex. Can you tell me whether or not it has a minimum or a maximum? Can you find the zeros or the roots of this function? Can you tell me how many there are? Can you find the y-intercept? And can you tell me the domain and the range? Okay, I want you to put them all down on this page. So I want the axis of symmetry. I want the vertex. Tell me, is it a minimum? Does this parabola have a minimum or a maximum? If you know that. What is the y-intercept? What are the zeros or the roots? And can you tell me the domain And can you tell me the range? When you're done, I'd like you to please tell me your definition of these words as they relate to parabolas, as they relate to quadratic functions. And I'll see you in class.